which of the differential equations are separable. And I encourage you to pause this video and see which of these are actually separable. Now, the way that I approach this is I try to solve for the derivative. And when I solve for the derivative, if I get dy dx is equal to some function of y times some other function of x, then I say, okay, this is separable, because I could rewrite this as, I could divide both sides by g of y, and I get 1 over g of y, which is itself a function of y, times dy is equal to h of x dx. You would go from this first equation to the second equation just by dividing both sides by g of y and multiplying both sides by dx. And then it's clear you have a separable equation. You can integrate both sides. But the key is, let's solve for the derivative and see if we can put this in a form where we have the product of a function of y times a function of x. So let's do it with this first one here. So let's see, if I subtract y from both sides, I'm just trying to solve for the derivative of y with respect to x. I'm going to get x times, all right, y prime is the derivative of y with respect to x, is equal to 3 minus y. So I subtracted y from both sides. Now let's see, if I divide both sides by x, I'm going to get the derivative of y with respect to x is equal to, actually I'm going to write it this way. I'm going to write it 3 minus y times 1 over x. And so it's clear I'm able to write the derivative as the product of a function of y and a function of x. So this indeed is separable. And I could show you, I can multiply both sides by dx, and I can divide both sides by 3 minus y now, and I would get 1 over 3 minus y dy is equal to 1 over x dx. So clearly, this one right over here is separable. Now let's do the second one, and I'm going to just do the same technique. I'll do it in a different color so we don't get all of our math all jumbled together. So in this second one, let's see, if I subtract the 2x, the 2y from both sides, so actually let me just do, let me do a couple of things at once. I'm going to subtract 2x from both sides. I am going to subtract 2y from both sides. So I'm going to subtract 2y from both sides. I'm going to add 1 to both sides. So I'm going to add 1 to both sides. And then what am I going to get if I do that? This is going to be 0, this is going to be 0, this is going to be 0. I'm going to have 2 times the derivative of y with respect to x is equal to negative 2x minus 2y plus 1. And now let's see, I can divide everything by 2. I would get the derivative of y with respect to x is equal to, and actually, yeah, I'm just going to divide by 2. So I'm going to get negative x minus y, and then I'm going to get plus 1/2. So it's not obvious to me how I can write this as a product of a function of x and a function of y. So this one does not feel, this one right over here is not separable. I don't know how to write this as a function of x times a function of y. So this one I'm going to say is not separable. Now this one, they've already written it for us as a function of x times a function of y. So this one is clearly separable right over here. And if you want me to do the separating, I can rewrite this as, well, this is dy dx. If I multiply both sides by dx and divide both sides by this right over here, I would get 1 over y squared plus y dy is equal to x squared plus x dx. So clearly separable. All right, now this last choice, this is interesting. They've essentially distributed the derivative right over here. So let's see, if we were to unfactor the derivative, I'm just going to solve for dy dx. So I'm going to factor it out. I'm going to get dy dx times x plus y is equal to x. Now if I were to divide both sides by x plus y, I'm going to get dy dx is equal to x over x plus y. And here, my algebraic toolkit of how do I separate x and y so I can write this as a function of x times a function of y, not obvious to me here. So this one is not separable. So only the first one and the third one.